Now in this video, I'm going to show you how to understand the inclined plane. Most of you have problems with finding the forces, the component of the forces along and perpendicular to the inclined plane. Right, so we're going to start with a very simple case of the inclined plane. So we do have an object that is on the inclined plane, that one that is in red. Right, so the mass of the object or the weight of the object is down the plane, vertically down, is shown. And then we do have the components of the weight along the plane and perpendicular to the plane. The weight of the object is mg, and then we do have these components along and perpendicular to the plane. Now, the inclined plane is at 30 degrees to the horizontal. So we want to find the weight in terms of, or the components of the weight along and perpendicular to the plane in terms of this angle 30 degrees. Now, we do have the reaction force from the plane itself, which I'm going to label R, right? And then we are going to split these triangles so that you understand. So as I said that this angle is 30 degrees, so we have a 60-degree angle over on the other side. So which means there's another triangle that is made that is the same angles as that one. As you can see, the angle 30 degrees is also shown in red, right, on that triangle. And then we do have a 60-degree angle, which is also shown in red. So if you study these angles, you find that the weight makes an angle of the component of the weight perpendicular to the plane makes an angle of 30 degrees with the vertical. Which means that if you resolve to be parallel to the plane, you are going to get an mg sine 30 degrees. And then if you resolve perpendicular to the plane, you are going to get an mg cos 30 degrees. Now, if we use the angle 60 degrees, the component perpendicular to the plane is going to be mg sine 60 degrees. And the component parallel to the plane is going to be mg cos 60 degrees. I hope that is understood. Now, I'm going to work out an example to show the application of what you've just learned. Now, the question reads, a 10 Newton weight rests on a smooth inclined plane. Then we've got a force of 5 Newton parallel to the plane, which is required to stop the weight from sliding down. So we want to find the angle theta as well as the reaction force R. So the diagram shows this inclined plane with the forces and the components of the weight. As we have said that along the plane, we do have mg sine theta. Perpendicular to the plane, we do have mg cos theta. So in this case, our weight is 10 newtons. So we've got 10 sine theta, which must be equal to the 5 Newton force which is going up, which we have been told in the question that it is responsible for maintaining the exact position of the object. So 10 sine theta is equal to 5 newtons. Making sine theta the subject of the formula, it's equal to 5 over 10, and then which is 0.5, and finally the sine inverse of that, that's 30 degrees. So which means that we can now apply this 30 degrees to the component perpendicular to the plane to find the direction force from the inclined plane. So R is equal to 10 cos 30 degrees. Now we know that plane is 30 degrees. So if you say 10 cos 30, you should get 8.67 newtons. If this is our direction force. I hope this video has helped you. Please do like, share, and comment on it, and remember to subscribe to the channel. Signing out.